All right, we're cruising along here. This is Summer 7.9. This is 7th grade curriculum, 9th chapter, geometric shapes and angles. So find the radius of a circle with a diameter of 17 inches. So when we talk about the radius, so if we look at a circle, let's get us a little circle here. And we know there are two important things that we need to recognize. We have the radius goes from the center of the circle out to the perimeter, or what we call the circumference when it's a circle. And then we have the diameter. The diameter goes from one side to the other. It is a chord, but it's a chord that goes through the center. So a chord goes from one point to another point on the circle. And this is a specific chord. This chord goes through the center. When it goes through the center, it's called the diameter. So the diameter and the radius. And we see that the diameter consists of two radii. So find the radius of a circle with a diameter of 17. So if this distance is 17, half of it would be 18. So 8.5. That's a horrible 5. Mr. Mac doesn't do his 5s that well. 5 inches. So 8 and 8 is 16 plus the 1/2 and a half makes 17. So 8.5 would be the radius. Find the circumference and the area of the circle. Use 3.14 or 22/7 for pi. Round your answer to the nearest hundredth if necessary. So this is interesting. Typically, you will see math books ask it, or will provide an answer in pi, and we'll show it. So the circumference, I don't like how we have A for circumference. C equals either 2 pi r or circumference equals pi d. You can use either of those formulas for the circumference. So since we're given the radius, we're going to use this one. So circumference equals 2 times 3.14 times the radius, which is 1 meter. Circumference equals, what's that, 6.28 times 1 meter, which gives us 6.28 meters. That would be the circumference around the circle. And then the area is going to be, this is the B part, and the area, formula for area is pi r squared. There is no other formula for diameter. You can't substitute diameter, even though 2 radius, this is radius times radius, where the diameter is radius plus radius. So there's only one equation. Area equals 3.14 times the radius quantity squared. So when we have 1 meter squared, that is going to be 1 meter squared. When we have 1 meter quantity squared, it equals 1 meter square. So 1 meter times 1 meter, you're going to multiply 1 times 1, which equals 1. Then you're going to multiply meters times meters and gives us meters squared. Completely different. Notice this square is outside. This square is only affecting the meter. So we'll do that, and we end up with 3.14 meters squared. Okay, so those are our two answers. Let's fix that decimal point, be a little bit more prominent. Boom. Circumference area, good. Squared units, that's good. Find the circumference and the area using 3.14. So this is a great question. Well, we'll show. Finding the circumference. So this time we're given the diameter. And I'm going to use 22/7 in this problem. I do like that they gave me this opportunity. They showed this problem because that's conducive. Any radius that is a multiple of 7 is going to be, we're going to use 22 over 7. Most of the other radii will use 3.14, but in this instance, we can cross cancel, so it makes it easier. 22 times 10 is 220 inches would be the distance around. The area, pi r squared, area, I'm still going to use 22 over 7 because my radius is going to be 45. No, not 45. It's going to be 35, excuse me. 35 inches squared. Now I can't cross cancel here. That would be division, and we have to square first. So we have to square that value before we cross cancel. 35 times 35 is a pretty big number. 25, that's 15, 17, that's 15, that's 1, 5, 2, 1, 2, 2. I think that's good. So times 1,225 meters, inches. Could have gotten away with that. Inches squared. And let's just check that and make sure that 35, 35, whoops, see, 35 squared equals, yep. And now we're going to cross cancel. 7 goes into this. 35 times 5 times. Don't know if you could see this, right? If this is 35 times 35, and then we would cancel one of the 35s by 7, that would leave us with 35 times 5. And we did 35 times 5, which was 175. Don't know if you saw that. That's 5 times 35. So area, whoa, not red. Area equals 22 times 175 inches squared. We can show this one. Here's another little trick. 22 times 175. I'm going to break the 22 into 2 times 11, because 11 times 175 I can do in my head. That's 1, that's 8. Oop, no, that's 9. Sorry, I was going to do it in my head. That is 9. That is 12, 5. So you get 1,925. And then we times it by 2, which we can do 3850. Let's check and see. 22 times 175 gives me 3850. Not bad. Not bad when we can do good math in our head, or somewhat. Inches squared. That would be the area of the circle with a diameter of 70. Diameter of 70 gives us a radius of 35. Find the perimeter. Oh, I like this question. This one's tricky. And the area of the figure. All right. So the area is going to be easier, but the perimeter. So the perimeter, and the reason they say perimeter is we need this distance around the circle, but it's only half of the circle. So we need half of the distance around a circle with a radius of, oh, well, actually we can do circumference. Circumference is pi d. So circumference equals 3.14 times the diameter. Circumference equals 12, 4, 9.42. Is that right? 9.42. 3 times 3.14. 9.42. Good. Now we have to take half because we only need half of the diameter. That is going to be 4.71. 4.71 is this distance, and then we have to add it to this area. This is a little bit different area. So if we want the distance around, we also have to add the diameter. So that's going to give us a total, we won't use C, we'll use P for perimeter. P is going to give us 7.71 feet. Now the area is going to be half of a circle. So pi r squared, area equals 3.14 times my radius, which is 1.5 feet squared. Guess I should have had a feet in there. That would have been more professional. So 1.5 squared, 15 squared is 225? 15 squared, 15 squared equals 225. Good. So we're going to move the decimal point 2 places. So it's 2.25. So 3.14 times 2.25 feet squared. So now we're going to multiply the 2.25. So let's divide that by 100 to get our, whoa, that was not times, that was the, gives us our 2.25 times 3.14, gives us 70.065. Area equals 7.065. That's 625? No, 7.065. That is feet squared. Now that is a full circle, so we need half of that circle. So the area is going to be half of that. So my area of the half circle is going to be 3.5325. And I think it says, oh yeah, I didn't see about the other rounding my answers. Sorry. To the nearest hundredth, that's to the hundredth, that's to the hundredth. We're okay with that. Round it to the nearest whole number. That's a whole number, that's a whole number. We're okay with that. Round your answer to the nearest hundredth. That's okay. This one is not. So my area is going to be 3 point to the nearest hundredth. So we go to the hundredths place. We have to look at the thousandths to tell us whether we're going to round up or hold. We are going to hold. So 3.53 feet squared would be my area of my half circle. Find the area, find the perimeter and the area of the figure. This isn't, we call these irregular figures, and we have to deconstruct. Some of you already see this. This is a triangle around a rectangle and a circle. So we got this triangle, and we've got 2 half circles. So we've really got 3 objects here. Perimeter will be able to do it. Perimeter is distance around, so that's going to be 8 plus 6. And then we need to find the distance around the circle. So as my little scratch work, we have to find the circumference of pi d. So circumference equals 3.14 times 8, which is 32, which is 11, which is 24, 25, 12, plus 25.12 plus, that's this around each circle, and then we need plus 10. So let's just make sure that 3.14 times 8, 3.14 times 8 gives us 2512. That was good. And now let's add those together. That's 14 plus 2512 plus 10 gives us 39.12 plus 10, which is 49.12 feet would be the perimeter. And now we want to find the area. And we have 3 objects that we're finding the area. Object 1 would be a circle, plus object 2, which would be a triangle, plus object 3, which is a rectangle. So let's find those. The circle is going to be area equals pi r squared. 3.14. My radius is 4 feet. Quantity squared. Area equals 3.14 times 16 feet squared. And 16 times 3.14. And let's just be efficient here. 3.14 times 16 gives us 5024. 5024 feet squared. The triangle is going to be area equals base times height divided by 2. So area equals base is 8 times 6 times, or divided by 2, which equals 48 divided by 2, which gives us 24 feet squared. And then my rectangle is going to be area equals base times height. Base is 10, height is 8. 10 times 8, which is 80 feet squared. Let's add those three together. That's 50.24. That's going to give us 104, which gives us 154.24 feet squared. I like that number. So the area, total area, is 154.24 feet. I'm going to stick with that. Tell whether it's possible to draw a figure with the given description. A triangle with side lengths 5 inches, 6 inches that meet at a 50-degree angle. Oh, that's very interesting. Okay, that meet at a 50-degree angle. So this is 90. So 50 is going to be more than 45. So this is 5. This is 6. This is 50. Okay, so what do we know? What do we know? We know that the other angles have to be side lengths 50, 60. I'm pretty sure that I don't see why not. You got 130 left in angle measure. That's okay. I don't know. I think you don't. Yeah, I mean, do we even have enough information? Well, like we did in the other one, let's take this question and put it into Gemini. And let's type it in there. Tell whether it is possible to draw a figure with the given description. And that information is a triangle with sides of length 5 inches and 6 inches that meet at a 50-degree angle. I think that's all they wanted. Is it possible? Let's see what good old Gemini. Yes, it's absolutely possible. In geometry, this falls into the sine angle side congruency theorem. Okay, but we're not showing congruency. When you're given the lengths of two sides of a specific angle, no, I don't want to know whether, I want to know whether you can draw it. Here's why it works in the foundation. Imagine drawing the first side 6 inches, angle at one of the 6-inch protractor, yes. Second line is 50 degrees, yep. And 5 inches, yep. Closing the shape at that point, all three vertices are completely fixed. To open, because the angle is fixed, the two sides can't swing open or close, meaning there's only one pot. Side angle side shows congruency between two figures, so we're not showing congruency. I'm not trying to show congruency. I'm just checking to see if it was possible. I kind of knew it was going to be possible. Got it, my bad. Overcomplicating the math jargon. Yes, you are. When you draw a triangle, you can run into impossible situations. Pieces again, give you the clue. Yep. Draw side 1 inch, 1 inch, and 10. Yes, I know that. That's exactly, but those are given 3 side lengths. But when you are given 2 sides and an angle between them, it's always be possible to draw. You just draw the 2 sides specific angle and then you connect. Yeah, exactly. That's what I had done. Okay. I just wanted to check. So yes, it is possible. Whoops. Whoa. What was going on there? Yes, it's possible. Tell whether it's possible to draw a figure with a given description. Side lengths 3, 4, and 5. Yes, okay. So 3, 4, 5. Yes, 3, 4, 5. 5 must be the hypotenuse. This is actually a right triangle. That's 9 plus 16 equals 25. And that's 3 squared plus 4 squared equals 5 squared. So that is Pythagorean theorem. Yes, it's possible. It doesn't have to be a right triangle either, but in that given example, that would be a right triangle. Tell whether it's possible to draw a figure with the given description. A quadrilateral with angle measures of 90, 110. So that's going to be greater than 90, 40, and 120. That's interesting. So that looks like 120. Yeah, those kind of look like it. Let's add them all up. 90, 110, 40, 120, 0, 6, 360. Yeah, that's good. I think that's possible. I think they have to add up the 360. 90, 90, 180. Yep, and it doesn't matter but a 4-sided 1, 2, 3. Oh, that's a 5-sided figure. Did I miss it? I missed it. Whoops. 1, 2, 3, 4. Yeah, but that's, I don't know how I drew a 5-sided figure. Sorry about that. But yes, a 4-sided figure, the angles should add up to 360. Pretty sure that's correct. Classify the pair of angles. Oh, I like this. This is good. So the angles are called supplementary. Supplementary add up to 180. They are adjacent to each other. They consist of a strain angle, 180 degrees. So supplementary equals 180, and complementary equals 90. So the way that I always remember it is smaller letter, smaller value. Bigger letter, bigger number, bigger value. So comp is 90, sup is 180. So we know that when we add these two together, that it's going to equal 180 degrees. So we'll simplify. We got 8x plus 76 equals 180. Let's now isolate the variable. 8x equals, that's 4, borrow, that's 10, 104 divided by 8. X gives us 13. So x equals 13 degrees. So this angle is 74, and this angle, x equals, well, we kind of knew what this was. I didn't even need to add those together. I actually could have subtracted. I knew that the sum of those equaled 74, equals 180. I could have subtracted 74 and seen that this had to equal 104 because they have to equal, that's not 104. Where'd I get 76? Oh, I got it right there. Sorry. That's going to actually be, 106 degrees. That equals 180. And then we had that 2 degrees there. So, okay. I think that was both of the questions. X equals 13. And those are adjacent, and they're also supplementary. classify the pair of angles. So here we have two that equal 90. So these are considered complementary angles. And we'll take the little shortcut here. Since it adds up to 90, this has to equal 34 degrees, right? 34 plus 56 makes 90. So this angle, x plus 6, must equal 34. We'll subtract 6. X equals 28. So the angles are complementary. And the value of x is 28 degrees. Actually, it's 28. Sorry, not 28 degrees. 28, and then the degrees come after. Oh, all right. These are called vertical angles. Vertical angles. Vertical angles are created when two lines intersect. There are actually two pairs of vertical angles in this diagram. You have this, these are vertical, and then you have these are also considered vertical. And then these would be supplementary, these would be supplementary, these would be supplementary, these would be supplementary. So, and then find the value of x. Vertical angles are congruent. So angle x are congruent, meaning they are equal. Congruent gives this sign. That's a congruency sign. And this is going to equal 113 degrees. Let's make sure that's all they wanted. And x. Yeah, x equals, oh, angles are vertical. Sorry. That's down here. And vertical goes here. Vertical. A museum plans to rope off the perimeter of an L-shaped exhibit. How much rope does it need? Well, we would add up each of these measures. Oh, I see what you did there. Okay. So we have to find this missing and this missing length. Technically, that's going to be 20 feet. This is going to be, well, let's move that inside here, that's, or down here, that's going to be 20 feet, and the green is going to be 40 feet. What we need to understand is that it doesn't matter how many times it breaks down and closes and stuff, that's going to be 40, this side's going to be 40, this is 60, this is always going to add up to 60. So we actually have a perimeter of 2 times 60 plus 2 times 40. That's 120 plus 80, or perimeter equals 200 feet. You'll see that. There's a very interesting, I forget what it is, where doesn't matter how many times you do it. Yeah, it was very interesting. I'll show this. It was a paradox. What's the paradox? What is the paradox about the perimeter of a triangle and breaking the hypotenuse up to sections? We'll see if they understand what I'm saying. There's a paradox about making it go up, down. Yeah, set up the paradox. 7, as you increase the number of steps towards infinity, the staircase gets smaller and smaller. Visually, the jagged steps become completely invisible and naked. Yes, and so that is really, really cool. This is what is this called? What's this paradox called? The staircase paradox. There's a really, really cool. We'll take a little time out and let's go here, YouTube. This is a really cool paradox. Where's a quick one? Let's do this. All right. Staircase. Let's do this one.
Got a minute for a mind-bending math
Yep,
paradox?
I got a minute.
Imagine climbing a staircase from one corner of a square to the opposite. You're covering the exact horizontal distance, 1 unit, and the exact vertical distance, 1 unit. So your total path length is always 2 units, no matter how many steps you take. Now here's where it gets wild. What if you could just fly directly from start to finish, cutting straight across the square? That's the diagonal path. By the Pythagorean theorem, its length is approximately square root of 2, which is 1.414 units. Your brain screams, how can the staircase that looks so much like the diagonal never get shorter? Why does it stubbornly stay at 2 when the actual straight path is 1.414? This is the staircase paradox. It shows how a sequence of shapes can visually...
That's not a very good explanation. I saw a better one. That's not the best example. I wish I saw where I saw it. I sort of had it. It's very, very interesting. You should check it out. But he sort of went into it in this little section here when he showed the units, how much you go. You go 1 and 1, which makes 2. And you can break it up into these little teeny steps right here, and it still ends up being 1 and 1, which makes 2. But when you go to, and you can get smaller and smaller and smaller, but once it becomes a diagonal, it ends up being the square root of 2, which is kind of cool. I don't know. That's a little weird tangent, but look up the staircase paradox. It's pretty interesting. I think it's interesting. Choose a pair of adjacent angles that are neither complementary nor supplementary. Well, that equals 90, so that's okay. That works. These add up to 90. That works. These add up to 180. That works. These add up to 80. Does not work. So these do not work. Do we have to find the one that doesn't? Yes, this is the one that is no. Nope. The circumference of a circle is 36.2 centimeters. What is the length of the diameter? So circumference equals pi d. We know what the circumference is, 36.2. And we know what pi is, 3.14. And we're solving for the diameter. So we will divide by 3.14, divide by 3.14. And using our handy dandy notebook, right? That is going to be 36.2 divided by 3.14, and we're rounding to the nearest hundredth. So hundredth would be here. So we're going to round that up. So that's 11.53. 11, no, don't want it in red. 11.53 centimeters. Good. Kind of cool. The circular rug is placed on a square floor. The rug touches all 4 walls. How much of the floor space is not covered by the rug? Round your answer to the nearest. So we have area of the shaded, we'll say the wood shaded, will equal the area of the square minus the area of the circle. So we'll say shaded. So area of the shaded equals area of the square, which is, the formula is s squared, minus area of a circle is pi r squared. So area of shaded equals s. Each side is 15, so 15 squared minus 3.14 times the radius. Radius is going to be half. This is the diameter, so that's going to be 7.5. Quantity squared. 15 squared, we've done that already today. 225. 3.14. 7.5 squared, we haven't done today. See, 7.5 squared gives us 5625. 5625. Let's multiply that by 3.14. Gives us 176,625. 176.625. So we'll subtract that. Let's remember it. Let's clear. Let's take 225 minus, oh, I forgot to do memory plus, sorry, not memory, remember. So that was 176.62525 gives us 48. Well, 48.375. And round to the nearest hundredth, tens, hundredths. We're going to round it up. 48.38 units are feet squared. That is the area of the wooden not taken up by the rug. So about 48.38 square feet of the floor space is not covering the rug. All right, that was good. Let's check our answers. 8.5. Yep, that's half. We remember that. We find the circumference 6.28 and 3.14. Yep, I remember that because the unit was 1, so that makes it a little bit easier. 220 and 3850. I remember the 3850. 220, I'm going to take my word for it. Oh, that's 3, 4, 7.71 and 3.53. I don't remember that one. 7.71 and 3.53. Let's check that. I think that is our 7.7, 3.53. Yep, that's good. That's good. So let's look at 5. 49.12, 154.24. Yep. It was possible. It was possible. Good. And it was possible. So all three were possible. Yep. So that's good to know. Supplementary. Yep. 13. Yes. Complementary. Good. 28. Yep. Vertical angles. 113. Yes. We got 200. Yep. Because it was 6120 by 80. And yes, that was the one that was not complementary or supplementary. And the circumference, the length of the diameter of the circle, 11.53. Yes, we rounded. And then 48.38. 48.38. 43.38. All right. Enjoy. We got only one more section left in chapter or in 7th grade material. Happy 4th of July.